Hello, Congress. Nice to see you again. And as usual, the only frontmen of SCADA StrangeLove team, and I know there are a lot of guys who help to make this talk. So if it's okay, please give hands to all SCADA StrangeLove team. Traditionally, we start our talk from the battle map when we show how many ICS systems connected to internet. But this time, we will skip this because of John. John, who built the Shodan, this year published excellent resource, icsmap.shodan.io, and you can download and check a lot of different ICS systems connected to the internet. And because John said thank to us, we say thank to John because he is an excellent guy, and thank you, John, again. But last year, after our talk, we received a lot of questions about this picture, about different type of connected system. And people said, okay, this is not ICS, this is some kind of honeypots maybe, or it's not serious, it's very small devices. It's not serious at all. So we decide to go deeper and check first one, IPCA chip. IPCA chip is a system on the chip which run real-time operating system with TCP/IP, web server, and security protocols. We love it. So we start to Google. Start from just a system name. We found that it have built-in CGI server with some built-in function. And during this assessment, we found interesting application of this chip. It's solar lock system. What is solar lock? Solar lock is kind of smart grid SCADA, small SCADA which you can install in your house to manage PV plant, which you can install on the roof of your house. But it generates about 7 gigawatts of instant output, and at the moment, about 1 million inverters connected to this system. Interesting. Because this system connects to some kind of the cloud, you can use it to find installations. No via Shodan, via boring network scanning, just visiting portal and check it. So this is Germany, and this is different location of installed systems. And also it has some kind of, I don't know, social networking features. So you can take a picture of your house, of your PV plant, share with your friend and say, oh, I'm saving energy I generated from my house personal power plant. But this is all about, you know, funny stuff. Let's go more deeper in technical side of this system.
Okay, it doesn't work. Oh, it's work. Okay, thanks. Well, first interesting thing, it's firmware. It's kind of software that gives you a lot of information how device works. Obviously, I think you know what it is. And most interesting things in firmware, it's configuration scripts, file system structure, and so on. And firstly, to find out through, for example, Google Docs, in simple case, you can use just Unix strings and grep. For example, in this case, to grep title, and as a result, through Google, you can find a lot of solar lock devices connected to internet. It's about 65,000. Of course, all of them are connected to internet and cached by Google. Well, and let's take a look on the authentication page of the solar lock web server. Simply, it's a poor authentication scheme, just only using password. All page using password authentication, But if you know appropriate full URL to download system backup, it's not a required password. Simply download. Well, just simply download system backup file, and what's most interesting thing in backup, it's of course username and passwords. Well, on this picture you can see simple encryption and all things that you need to decrypt. Another one, typical process for firmware and devices, it's firmware update. Well, following SolarLog update process, you can see that it's highlighted part. On the screenshot, you can give a full path to system. If you know what file system structure, simply it's DOS operation system, like a DOS, yes, sure. And you can override system files, configuration files, and so on. Sergey?
So it was fixed. It was fixed with collaboration with computer emergency response team of German government, and thank them. But you know, because this is just a platform, I guess that there are a lot of different producers, manufacturers, vendors who use this platform to build other devices. So I'm not sure that all of these simple bugs was fixed. It was a funny story, but you know, we forgot about it, already forgot. But one day I saw this Twitter. And I understood that maybe solar panels not so renewable. And maybe we should use our power, our knowledge to save sun. So we decided to understand a bit more about all this green energy. And if you want to get new knowledge, what you should do? You should go to Germany, to Hamburg, to Congress Center, but not at Congress, but to Wind Energy, Hamburg. So we virtually visit this exhibition and got a lot of information on different wind and solar equipment. And start from simple stuff. Shodan again, we found a very common system, Sunny Web Box. As you can see, simple Shodan search give us about 80,000 of devices connected to the internet. Alex?
Well, first notice about Sunny WebEx default password was 3 years ago in full disclosure list. It was default SMA uppercase password. It's first type of the password. Okay, so we decided to read the first manual, of course, and we noticed that username installer has different, as previously mentioned, password. It's SMA lowercase. Okay, so we decided to go deeper to read in the first manual, and we find out that it has user and installer groups, usernames, and different passwords. It only contains numbers. Okay, so what's the true password at the final? And real researchers, real hackers trying to give it by your hands, and we discovered interesting things in firmware that it contains not only user and installer password, it has also service and developer system accounts, and also it has interesting strings, interesting password mode, like hard-coded passwords.
So we can say what password is, because it's hard-coded, very hard. But what we can say that quick Google search for these devices allow by analyzing of responses, because on the response you can find amount of energy generated by this device, allow you to find about 100 of megawatts of energy. If we compare to different generators, like hydroelectric station, it's like small Elpin hydroelectric station near Selamzi in Austria. So this amount of energy generated by solar rock can be found via Google. But via Shodan and different types of full internet scanning, you can find 20 times more energy if you need the power. But it's all about sun. Let's talk about wind. Because you know, all this big stuff, I think it's killing wind. Simple stuff, again, very simple stuff. I found very old storage Shodan search, which helps me to find about 300 of systems. Name of the system is Nordex NC2. Just quick search of vulnerabilities in this system. On this system, demonstrate that this system have a long story of vulnerabilities, starting from 2010 and finishing 2013. What's interesting? I think those vulnerability not patched. Why? Because if we check response of this service, we can find that this server works on the system which already deprecated. So it's version number 3 web server of web server, Jetty web server, current version in number 9. Also, it works on the very, very old version of SCADA. Simple CVS details search demonstrate that since 2002, people publish information about vulnerabilities in this web service. So I don't want to talk about vulnerabilities in Mama reel-to-reel recorder. It's even not script kiddie stuff. But if you want to understand how it's look in real life, I took 2 pictures from Google. One picture is Nordex wind turb, and second is management interface. Only for Google, it's not real. So how much energy we can get in this case? About 1 gigawatts. So if we compare with different generation, it's absolutely the same. Like help me. It's Stuxnet was in Iran on Bushehr nuclear plant. The same. So anybody who know how to read Adwiner, there is can write on Stuxnet now. So just to finish this part of our talk, by simple, very simple vulnerabilities, we found about 8 gigawatts of instant power energy. If we compare it with most famous, most powerful hydroelectric station, it's number 5 on the list. It took 2 days after the war. So let's continue our saga. And talk a little bit about our famous vendor. What the similarities between Large Hadron Collider and, for instance, gas pipe. It's a semantic WinCC open architecture. It's very popular HMI, quite new system, but it also have new web server. I think if you was on our previous talk last year, you can remind this picture. This is a history of bugs in Apache web server. Why are we talking about it? Because if you going to write your own web server, please carefully review all vulnerabilities discovered during when other guys wrote own web servers. Just to remind the history of different funny web vulnerabilities. This was discovered several years ago, if you send incorrect HTTP request to web server without HTTP body, it can crash. This was discovered in 2000, in year 2000, in Internet Information Server, and you can use path traversal to read, write different folders. I think you can remind these vulnerabilities was related to one worm. And another one related to incorrect content len. So you can put big amount of data, but say that is very short, so you can overwrite memory. Why I'm talking about this old stuff now? Because I want to show you a small movie. Just a second. Here it is. Oh. So let's launch WinCC on the debugger to see all the process and submit very complex request with thousands of AAA, lot of AAA. What we will get? We will get break with typical 31, 31, 31, 31. I think it's AAA also. But if you will send, okay, if you will send more complex request, what we get? Calculator. I think SCADA. SCADA must have ability to calculate something. For sure, it was fixed. We don't disclose 0 days, but I like this comment. So if CERN update to version 3.12 of thematic WinCC OA, we can stop terrorists who clearly evil genius, accessing Large Hadron Collider and create a black hole that will shallow up the world. So we save the universe. Let's take time machine and come to the past, to the Miami at the S4 conference. It's a conference dedicated to SCADA safety and security. And what we show when, on this conference, this slide, I think you also can remind it, demonstrate average age of the libraries included in WinCC HMI. So you can see that most of the HMI was compiled before the Stuxnet. And on this conference, we demonstrate how to find 0 day using find. So you just get the list of the files in software and try to find most old one. In this, we found OpenSSL, compiled in 2007. And we say to Siemens, guys, let's update your software. And this was a mistake. Why? Because old version of OpenSSL does not have Heartbleed vulnerability. And after update, we get Heartbleed vulnerability, and Large Hadron Collider get Heartbleed. Just to demonstrate how it's works. Nothing special, but I'm sorry. So we're running a standard Heartbleed handler, which require memory from the SSL server, and trying to authenticate with username and password, and get username and password from the server because of Heartbleed vulnerability. It's base 64 encoded, so we need to decode it. And let's try again with stolen username and password. It should work. Here it is. So, simple vulnerability, everybody know about it. Not so simple, but white know, yes? And what I want, why I show this demo? To highlight one important thing. People can ask me, okay, first you say, please don't write your own web server. But after you say it, please don't use third-party components. What to do? I don't have answer. But anyway, if you decide to write on the server or to use third-party components, please care about security. If you include, I don't know, OpenSSL or Bash shell in your software, please update it, please check it, please care about it. Alexander?
Well, so another one vulnerability to its long story. About SQL injection that was first published 1.5 years ago. It was simply SQL injection via arbitrary SQL commands with unspecific vectors. SQL injection, unspecific vectors. Well, what does it mean? I don't know. Okay, well, and Cisco give us excellent decision how to avoid this vulnerability. Simply deny connections to web server ports. Well, okay, it works, sometimes it works, but SCADA components, industrial control system components, it has a lot of protocols, communication processes, it depends on functionality, and in this case, WinCC server has not only SYN client, it also has a SIG client. Well, it works on RPC protocol, and well, firstly, when we trying to authenticate, we noticed clear text messages. As you can see, it's user year and next password year. Well, it's clear text, but we spent a few minutes, and after we noticed that authentication data goes to WinCC server on the different port, and it's not clear text. Well, where is password? It's no clear text. Maybe it looks like some encryption.
Yeah, it's kind of encryption. And I think everybody who saw our previous talk already know encryption key. You're right, this is my encryption key. But this was fixed, and it was fixed with new encryption key. And first of you who guess new lead encryption key, give lead prize or free beer from SCADA StrangeLove team. Huh?
Secret key?
No. It's lead. Good guess, but not right. Excellent answer. But it's very lead. Okay, first of you who said 32 new key and something else, come on after the talk on the stage. I had a lot of souvenirs, but this is lead encryption key. But it was fixed again. We doesn't check it yet.
And another one interesting story, it's about cookies. And once upon a time, we tried to discover interesting things, authentication on a Siemens Semantic PLC controller, and we discovered interesting thing that cookies contains constant parts and changeable big part of the cookie. Okay, so we decided to go deeper and to understand what's going on with cookies. And well, it's first biggest party of the cookie. It's MD5 of some value. Well, so what about its value? After spending some time to reverse engineering PLC controller firmware, we found out that MD5 it's from the cookie, 26 bytes of all the cookie and 16 bytes of the secret, and plus 2 bytes of null. Well, what's about secret? Usually secret generates, it's a typical practical approach, secret generates after PLC start and it uses PRNG. PRNG was a little bit harder than a standard C PRNG generator, and seed was 2 bytes value. Well, it's time to brute force, as you can see, but it's too much values to brute force because PLC is so tender. And what about seed? Seed very often, it's also a typical approach. It's very often depends on time value. And by our practical research, it was PLC start time plus some constant value. Well, constant value using current time. Next step was how to obtain PLC start time. It's obvious that we can use values from a web server page, its current value, and uptime. Uptime we can get through SNMP request. Great. It's time for demo, and as a result,
once again, just a second. Okay,
it started. Well, I'm not a master of movie maker. I should improve my skills. Well, let's imagine that attacker connected to entire network. Let's ensure that attacker on the network one, for example. And first of all, we try to find out devices that support Profinet protocol. We find PLC controller, and you can see that it has a different than attacker side IP address. Okay, let's ensure that it's not accessible. Next step, it's using a Python script to change network settings on PLC controller using a Profinet specially crafted Profinet request. Well, we provide to Python script destination MAC address, our source MAC address. Well, it's simple way to get your MAC address of your network interface, and provide network settings for new network settings on PLC controller. Simply, it's IP address, network mask, and gateway.
Don't type too fast.
Yeah. Well, we received answer. It's cool. Well, let's ensure again that network settings changed on PLC controller. Well, it means that we bring a PLC controller to our local subnet. It's accessible. Great. So the next step, let's imagine it's one of the dependency of vulnerability. Let's imagine that real user, for example, SCADA engineer, going through browser to PLC controller and simply authenticate it using login and username, real login and username. Okay, who guess what the password?
Star.
Well, you can see that controller on the operation mode run. Next, So we see that cookies stored on browser. Well, it's the next very important step from attacker side. It gets very important values from controller. It's its range. And the final step is run a Python script to brute force cookie. And we provide to the script seed values. It depends on how many times authenticated user on the controller. It can take from few seconds to some minutes. Well, let's clear our cookies. Everything real on this video. Well, we clear cookies and prepare to put new cookie values. It's still brute forcing. It's only one cookie with the name Siemens SCADA session and big value that we will give a little bit later. Okay, it's a typical scenario.
No industrial process running at this moment because PLC brute force it.
Yep. We found two real cookie values, and I like kill to send process. And the final, let's copy paste cookie value to the browser and reload the page and ensure that we are authenticated user, administrator, and stop PLC, stop some process. Well, as you can see, we don't need any username, password, and so on. Only connected to our subnetwork PLC controller. Thank you.
What I want to highlight in this vulnerability, for sure it was fixed, but here 2 points. First point, we found it because of Congress. Because on 29 C3, we participate workshop, and one of guy who was on this workshop say, okay, did you check the cookies? We say, no, I don't believe it. On such small device, authentication process realized it correctly. So after this idea, we start working and find this vulnerability. It's already fixed and it's okay. And second thing I want to highlight, it's communication about SNMP communication. Started from January, we have a long story of communication with Siemens about SNMP hard-coded community. They say, okay, this is not issue, but in the end, they say, okay, this is issue, because via this vulnerability, you can get the cookie. So what I want to highlight, if you make something, please care about basic thing. Everybody works on SNMP v3 and don't use hard-coded password. Why to do it on the new system like PLC 1500 or 1500? But please don't think that we hate Siemens or something. We're speaking a lot of about Siemens because now we're in Germany. If we will be in French, we will speak about Schneider Electric. If we will be in US, we will speak about Honeywell. And you know, really happiest day in my life when we get answers that vulnerabilities was fixes. It's emails from Siemens product cert, and I want to thanks Siemens, all the Siemens team, and especially Siemens product cert for hard job. And please give them your hands. And guys, if you here, and I know you here, please catch me after the talk. I have souvenirs for you. So this is our traditional slide with number of vulnerabilities discovered in different platforms. For last 2 years, Siemens was the first, but now you can say that Schneider Electric, mostly because of acquiring of Invensys, have a first place on the discovered and not patched vulnerabilities. And many people asking us, what is your approach to discover so many vulnerabilities? I have an answer, because we're too lazy. This year, we decide to not discover vulnerabilities by ourselves. We built big test bed with real SCADA PLCs RTU system connected to toll railroad and say to everybody, guys, you can connect here and hack it. If you can make disaster, you will get prize. If you will find 0 day, it's your 0 day, but please follow responsible disclosure. So for 2 days of Positive Hack Days forum, guys and girls found more than 10 0 days in Indusoft, in Sematic, and IPC RTU, IPC DAS RTU. It's Taiwan RTU, like on no name. So now responsible disclosure in progress, waiting for the fixes. We're talking about vulnerabilities, and I want to talk about math. Sometimes math not so hard science. So in this case, we submitted about 10 vulnerabilities, 9 vulnerabilities to vendor, and get response that all vulnerabilities is fixed. But in advisory, we found only 2. I don't know, shall we trust vendor? Maybe not, but what I want to highlight, sometimes it's very bad idea to create a false feeling of safety. Because if somebody read this advisory, he can say, okay, if CVE is 6.2, it's not very important, I will not update this system. But in reality, several remote code execution without authentication is here. So it's better to speak the truth. Postscriptum. Very long postscriptum. Anybody here know the difference between picture 1 and picture 2? Okay, different question. What is bad, 1 or 2? Green light or yellow light? Somebody? Green. Okay. First who say green have special prize. I will say why. Let's talk about functional safety, because you know now we're speaking about vulnerability. Okay, we root, woohoo, but when you are talking with industrial people, they say, and so on. So what? Okay, you root, but I have a special SIS system, I have special protection system which does not allow disaster. I want to demonstrate how very simple vulnerabilities can lead to very serious problems. First, super heavy trains. I think you know what is super heavy trains. It's very big trains with several locomotives which sometimes synchronize engines by the radio channel. One on the beginning, one in the middle, always the end, and they synchronize engines and brakes via radio channel. Why? We do it because we need run synchronously. So let's imagine that somebody run a small radio jammer. And it's a very long device with several locomotives. And they starts run asynchronously, and train just goes in different dimensions. So also, it's a very interesting answer. Typically, you can get it if you speak with industrial people about CO4. Anybody here know what is safety integrity layers? Think a lot of people, yeah. So when you say, okay, you have problem, we have CO4, we don't care. What is CO4? It's safety integrity layer. It's demonstrate a probability of failure. For different process, it can be the probability of error on demand when you ask in system. If it's continuous process, it's probability of failure per hour. You can see that this is very big number. So probability of failure very small number. So if this system really have CO4, it should not break ever. But if we get root on this system in 50 minutes, does it still have CO4? My answer, no. And I have a very interesting discussion with a developer of one system. After demonstration, like our team can change the road and manage switch on CO4 certificate system, he said, you know, this is not my system. I saw you upload wrong firmware. You rooted and upload wrong firmware, and now this is not my system. Before you rooted, it was my system. You know, it's like with people. Sometimes in amok or in, special kind of mindset, you can do very bad things, but this is not you, and this not my system anymore. So I think now we know the difference. A green light is bad. Why? Because of green light, train will go on highest speed to the curve. And sometimes it can be very bad. On yellow light, it will drop speed and move more slowly. And real postscriptum. I think a lot of people here know what is network convergence. So it's especially in telecom environment when different type of communication protocol goes to the same basic like IPv6 or IPv4, and PSTN goes to IP, and mobile goes for 3G, and so on, so on. So all different systems connected together using same basic. But what we see at the moment, it's operation technology convergence. We see that modern smart grid use protocols and technologies from ICS, sometimes mobile connection, sometimes billing and payment to understand how many power you generate, and so on, cloud technology. So we see like different technologies come together to maybe make our world better. And for last year, we heard a lot of talk on different conferences. For instance, on Black Hat, we spoke about how to hack ATM. In PACSEC in Tokyo, we spoke about how to get root via SMS. And also, we spoke about the Great Train cyber robbery on FOSIX. But you know, all this about same things. We cannot say at the moment. Why? Because we don't know yet. But what we know, our world now, it's very complex and very gentle things. So let's invest, let's use our power to keep it safe. Maybe not safe because it's too hard, but at least peaceful. Thank you.
Thank you. Thank you very much, Sergey and Alexander. Now for the questions, could you please line up at the microphones here in the middle of the room? And as I can see, we have no questions from the internet, nothing from IRC. Thank you, TriLoader, for monitoring the internet, our signal angel. How about questions from the room? Yes, microphone number 1, please.
Yeah, hello, my name is Dirk Möbius. I'm working as a software developer in railway technologies. And I would just like to add concerning the level 4 safety level. Yes, risk is against failure. Yes, everything which is currently in railway technology implemented is against failure, not against sabotage. If you would, maybe we can take later about that.
I understand. Yeah, you're absolutely right. The safety don't think about the people.
If you know how railway technology works, you can sabotage everything from Excel counters to point machines. You can crash any train. Yes, because at least you're going to the hardware and disconnect the wires. Yeah. So it's about detecting failures, not about being able to prevent sabotage. Not yet, we're working on it, but that's another talk.
I understood you absolutely, because, you know, which is why when I talk with people who work in industrial system, I prefer use not safety or security or in the information security. I prefer to use term cyber security. Yeah. It's like a combination of safety, industry security, and information security, and you can demonstrate how information security can broke security features, safety features, put it on the, for instance, row.
Just let's talk after the talk.
Okay, thank you. Yeah.
Okay, thank you. Any more questions from the room? Nobody lined up at a microphone. Well, this is the time to say thank you very much again.
Thank you.
Alexander, Sergey.
Thank you.